Place value mats are simple mats divided into 2 or 3 sections to hold ones and tens or ones, tens, and hundreds. You can tell the students that these mats are good ways to organize their materials when working with base 10 blocks. The standard way to use a place value mat is with the space for the ones on the right and the tens and hundreds place values to the left. As the students use these mats, teachers need to let the students know that left to right order of the pieces on the mat is the way they write the numbers. Students can use place value cards to build numbers. They will need place value cards for the hundreds, the tens, and the ones to build these numbers. As students place the materials for a number, for example 457 on the mat, have them also use the place value matching cards. So they would need a 400, a 50, and a 7 to match the materials on the place value mat. The 5 levels of place value understanding are single numeral, position names, face value, transition to place value, and fully understanding. To understand where the students are, you will need to do a couple different types of interviews with the students. The first interview is referred to as the digital corresponding task. Take out 36 blocks, ask the students to count the blocks, and then have the students write the number that tells how many there are. You can circle the 6 and 36 and ask, does this part of the 36 have anything to do with how many blocks there are? Then circle the 3 and repeat the question. As with all diagnostic interviews, do not give clues. For the second interview, write 342 down. Have the students read the number, then have the students write the number that is 1 more. Next, ask the students for a number that is 10 more. You may wish to explore further with models, maybe such as 1 less and 10 less. Watch as the student is counting on or counting back, or whether the students immediately know that 10 more is 352. A third interview can also provide interesting evidence of depth of understanding. Ask the student to write the number that represents 5 tens, 2 ones, 3 hundreds. The students may or may not notice that this is the tens, the ones, and hundreds are not in order. Notice if the student writes or does not write 352, then ask the student to show the number with base 10 materials and to say what number they have with all the materials. A useful version of the hundreds chart can be made of transparent pockets into which each of the 100 numeral cards can be inserted. You can also cover the numbers, give students numbers to place on the chart, or highlight patterns such as skip counting by 2s, evens, 5s, and 10s. In kindergarten and first grade, students can count and recognize 2-digit numbers on the hundreds chart, including decade numbers from 10 to 100. Also, first graders can use the hundreds chart to develop a base 10 understanding of adding 2-digit numbers with multiples of 10. There are a lot of patterns on the hundreds chart. Here are some. The students can find the numbers in all columns end with the same number, which is the same as the numbers at the top of the chart. In a row, the first number, 10's digit, stays the same. In the second row, the 1's digit counts 1, 2, 3, and so on to 9, 0. Changes as they move across. In a column, the first number, 10's digit, counts or goes up by 1's as you move down. You can count by 10's going down the far right hand column. And starting at 11 and moving down at a diagonal, you can find the numbers with the same digit in the tens and the ones. Example, 11, 22, 33, 44, and so on. Relative magnitude refers to the size relationship one number has with another. Is it much larger, much smaller, close, or about the same? How students think about these comparisons is supported by the use of models and by the development of benchmark numbers, and that they can be used as signposts for a number's location as a number line. A valuable feature of both the hundreds chart and the little 10 frame cards is how clearly they illustrate the distance to the next multiple of 10. The number of spaces to the end of the row on the chart or the blank spaces on the tip stream card. Multiples of 10, 100, and occasionally other numbers. Some activity examples of relative magnitude using benchmark numbers are on page 230 and 231 in your textbooks. Activity 10.17 is shown on the PowerPoint slide, but 10.18 and 10.19 are also good examples. As the students in our classes study place value concepts, encourage them to notice numbers in the real world around them. In kindergarten first, they should be thinking about numbers to 100 or 120, while in second grade they should be thinking of up to 1,000. Ask students where they can find these numbers in the school. You might use the numbers of children in third grade, the number of minutes devoted to mathematics each week, or the number of days since school has started. There are measurements, numbers discovered on field trips, numbers in books, and other subject areas. What do you think of these numbers? Turn them into interesting graphs, write stories using them, make up problems. For students to have good concepts of numbers beyond 1,000, the place value ideas that they have been carefully developed must be extended. This development sometimes is difficult to do because physical models of thousands are not readily available, or easy to come by, or easy to use. Two important ideas for development for three-digit numbers must be extended to larger numbers as students move to thinking about 1 million by fourth grade. First, the multiplicative structure of the number system should be generalized. Tens in any position make a single thing called a group. In the next position to the left and vice versa. Second, the oral and written patterns of numbers in three digits are duplicated in a clever way for every three digit to the left. Two related ideas are not as easy for students to understand as adults think they are. When using cubes, you can have students make 10 cubes that make a long, then 10 big longs make a flat, and big flats will make an even bigger cube. At the bottom, there is a place value chart, and if you notice in the green, the units. 1 cube is a unit, 1 long is 10 units, 1 flat is 100 units. This continues with thousands, millions, and billions. A cube is 1,000, a long is 10,000s, a flat is 100,000s. 1 cube is 1 million, 1 long is 10 million, and 1 flat is 100 million. Remind students not to use the word and. For example, 106 should be 106, not 106. Some misconceptions / errors. Students lose track of the fact that each digit in a multi-digit number carries a value dependent on its position in the number line. Ways to help that: use base 10 materials and have students show materials with the value of these two numbers. For number 2, have students use virtual base 10 materials that display the corresponding numbers to check the answer. Number 2, have students use base 10 materials to count out 13 single units. Then ask them to compare the amount to what they previously shown. Number 3, students must practice reading numbers without using the word and. Number 4, provide examples of the actual materials on a place value mat and use the place value cards to show how the matching numbers build. Number 5, focus on meaning of the number 0 and any number of starting with a number like 408 and asking how that would be shown with materials. Number 6, go back to the base 10 materials and use the place value mat to take out the same amount of base 10 materials as in the number. And number 7, particularly with thousands place value block, if students don't see the building of the block groups into a unit, they may be confused with the value. So show the building of the cube by taking the 10 hundredths block and forming a cube with them.